Alrighty then, corn children, children of the corn, it is a fine day for mathematics. Yes, it is. Today we're going to be reviewing right triangle trigonometry. Some of you may know it by the mnemonic device SohCahToa. That stands for our three basic trig functions: sine, cosine, and tangent. So let's see how this works. You'll notice that I have drawn for myself a right triangle. Yes, I have. Now, right triangles have three angles and three sides. One angle here is a right angle. I'm going to choose to stand at this angle right here. And I'm going to mark the spot with the Greek letter theta. Now, there's me. All right. The trigonometry is based on which angle you're standing at. So, if I am standing here at this angle, the side that is all the way on the other side from me, all the way across from me, that side is called the opposite side. Now, this longest side, which is across from the right angle, is called the hypotenuse. Whew, that was hard to spell sideways. And then this last side that is next to where I'm standing, but not the hypotenuse, but next to where I'm standing, fancy word for next to is adjacent. Yes, it is. All right, so our three trig functions, sine, cosine, and tangent, they are all functions. Something goes in, something comes out. Now, the sine function. The sine function requires you to put in the angle size where you are standing. So this is a function machine. I could write it with parentheses, theta going into the sine machine. So the size of the angle goes in, and with the sine machine, it is the length of the opposite side divided by the length of the hypotenuse that comes out. Sine, or so, sine opposite hypotenuse, sine opposite hypotenuse. Cosine, again, requires you to fill in the angle size where you're standing. What comes out of the cosine machine is the length of the adjacent side to where you're standing over the length of the hypotenuse. Yeah, it's the ka of SohCahToa. Tangent of theta. The size of the angle where you're standing is going in, and what comes out of our machine is the length of the opposite divided by the length of the adjacent. That's the toa of SohCahToa, toa. Now, we can use these to find missing sides or missing angles in a right triangle. Yeah, let's do an example or 7. Come on, it'll be fun. Here's a festive example. Yep. Now, let's suppose someone has come along and they have measured this angle up here to be 23 degrees. Okay, I need you to stop and pause right there. There's more than one way to measure an angle. Yeah, it's kind of like you can measure a length with inches or meters or centimeters. There's different ways to measure. Because I have labeled this with degrees, it will be important that when you work with your calculator, that you go into the mode feature and make sure that it is also in degree mode. You'll notice I have a box on the word degree. Very important. Okay, so we have this 23 degrees measured for us, and let us suppose that we wish to know the length of that vertical side, which I'm marking with an X, and someone has come along and told me the length of the hypotenuse is 56 inches. We can use trigonometry. Picture yourself standing right there at the 23. If you're standing at the 23, this bottom side is the opposite. The hypotenuse is the longest side, which is also across from the right angle. And the X marks the adjacent side. Now, here's the deal. We don't know the opposite. We don't want to know the opposite, so I'm going to ignore that. I want to know the adjacent. I do know the hypotenuse. If only there was a trig function that worked with adjacent and hypotenuse. Cosine works with the adjacent and hypotenuse, and I write an equation. Cosine of, where were you standing? 23 degrees. Will equal the adjacent, which we're calling x, over the length of the hypotenuse, which is 56. Yeah, I know, right? Now, our job is to solve for x. This means division. To undo it, I would, of course, multiply by 56 on both sides. They cancel here, and I have x equals 56 multiplied by the cosine of 23. If you have an even remotely decent calculator, you can just straight up type it in. And if I wanted to round this to the third decimal point, 51.548. Now, if this side is in inches, the other sides would also be in inches. Now, once I have this side, I could find the opposite if I wanted to using either trigonometry or your friend and mine, Pythagoras. A squared plus b squared is c squared. Yeah. Not only can I use trigonometry to find a missing side, but I can use inverse trig to find a missing angle. Come along. Here's another triangle. Oh, yes. Look how terrifying that is. The right angle's way up there. And this time I wish to know this angle and have been told that this side is, 97 centimeters, almost a meter, almost a something. And this over here is 50 centimeters. Well, first of all, let's just remain calm. A triangle drawn this way is the same process as a triangle drawn that way. If it's going to freak you out, turn your paper. Okay, all right. So I'm going to stand here at the X. Yeah, there I am. Now, if I'm standing at this X, this would be opposite of me. The hypotenuse is down here. I'm not even going to label it. Why not? Don't know it, don't want to know it, don't care. This side then would be the adjacent side. If only there was a trig function that worked with opposite and adjacent. I think there is. It's called tangent. Now, into the tangent function, I need to fill in the variable x. That's where I was standing. X is the size of the angle. Interesting. Tangent is opposite over adjacent. Now, we would need to know a little bit about inverse functions. A function gives you an in and an out. The inverse function switches the in and the out. The out becomes the in and the in becomes the out. So, what is the notation for the undoing of tangent? Well, there's actually two. Yes, two. We could work with inverse tangent, or we can work with arctangent. Now, here's how this works. In our tangent equation, the x is the in, and this fraction is, nice arrow, is the out. When we switch to inverse tangent, the out becomes the in, and the in becomes the out. Oh, that is a thing of beauty. The notation here would be the same. And If your calculator is in degree mode, this angle will come out in degrees. Let's see how that works. Where, oh where is our inverse tangent button? I don't know, can you see it? On my calculator, in blue, right above tangent, it has tangent with the little -1. Yeah, that's it. Since it's blue, I use the second key, then the tangent key, and sure enough, inverse tangent sits on the screen. I do inverse tangent, 97 divide 50, and there, ladies and gentlemen, 62.731 is x. Enjoy.